So basically, for this lesson, we are taking an equation. Like, what are the takeaways? The takeaway is this. We are taking an exponential equation that might look like this. A, and then there's something b to the power of k x minus d plus c, right? So what does the b stand for?
Base.
The base. And then we have a vertical stretch, k horizontal stretch, d, c, right? So there are 4 transformations. However, what we learned in today's lesson is by doing exponent laws backwards. So do exponent laws backwards. Okay. What we're able to do is write the exact same equation in a much simpler format, where the capital A is not the exact same as lowercase a, right? That might change. B to the power of a single x plus c. Zach, if you can't see well, you can always move over. Okay. So do you see the difference? Right? We're going from an original equation that has potentially 4 transformations to moving over to an equation that only has 2. Okay? And how do we do it? We do exponent laws backwards. That's why when we did the warm-up yesterday, we practiced the exponent laws, and then I told you guys, do them backwards. Okay? The 2 big ones that we looked at yesterday were this. If I have 2 to the power of x plus 3, this is the product rule for the exponent laws, and doing it backwards means I break it up into 2 to the power of x times 2 to the power of 3. Okay, so this is the first sort of skill or trick that we do in this lesson. The second skill or trick is that if I have 2 to the power, actually, let me change it to a different base. Let's say if I have 3 to the power of 4x, this is the power to a power law. And if I do it backwards, I break it up. I always take the integer exponent first. So it's 3 to the power of 4, all to the power of x. Okay, so these are the 2 tricks, if you want to call them that. And then we're like, oh, 2 to the power of 8, 2 to the power of 3, well, that's just 8. And 3 to the power of 4, I picked a... Yeah, maybe it's 81. Yeah, so I'm like, okay, no big deal. 81 to the power of x, where this one becomes 8 times 2 to the power of x. So the whole idea, once again, is to simplify. Right? We're taking something really complicated and trying to simplify it. In this case, our method is doing exponent laws backwards. Then we had 2 important notes to notice. When I am undoing, actually, take this back. When I start off with a d value, so like this light blue example, I have a d value of -3, right? When I simplify and get rid of that d value, I have changed which part? Yeah. It's becoming an a value. Okay, so do you see this 8 in front? That's my capital A. So what we want to say, I know we wrote it once, you can write it again if you want. D becomes a value. And if you already have an a value, then this will multiply. Now, it's not straight up. It's not like 3 becomes a, but it gets absorbed into the a. Whereas if I have a k, right, in this case, 4 is a k value, where does that get absorbed into? Look at the 81x. Yeah, the base, the 81 changes. So the k, maybe it changes. Maybe that's a better word. The b value. And I think I want to change that d changes the a value. I think I like that word better. So d changes. And so what we're going to do today is we're going to have both a d value and a k value. So we're just taking what we did yesterday and combining it so that we have both of them. Okay? We good here? All right. So let's turn to question 12. And so we are asked to take this equation and simplify it in the form of uppercase A, bx plus c. Okay, so we want to get rid of the d value. So once again, let's predict where the d will go. Okay, if I have d equals -3, what will change? Will it be the uppercase A or the base? Good. How do I know that? Well, I have it here. If I have a d value, it will change the a. So I'm kind of thinking ahead. What kind of answer am I looking for? Do you think anything will change the c value? Right? It seems like the c value just gets left behind. Okay, interesting. And that kind of makes sense. Do you know why? What on the graph, what does the c value represent? The asymptote, right? So if we're keeping the exact same equation, just changing the format, we don't want to change the asymptote. All right. So we expect that a will change, right? This is my prediction. And folks, this prediction is the type of skill you want to do for the thinking inquiry questions, right? If you can understand this, you're going to be more equipped for thinking inquiry questions. All right. So let's start off. We've got f of x equals. Now the x plus 3, which law are we undoing? Undo the product rule. Oh, that doesn't look very clear. Undo the product rule. Right, so that's telling us the product rule is this. X, y plus z equals x to the power of y times x to the power of z. So go ahead and do the next step for this simplification. Undo the product rule. Okay, so we're going to have 2 to the power of x times 2 to the power of positive 3. And then we don't forget that minus 5. Okay, if a base has a numeric exponent, let's find the value. So 2 to the power of 3 is just 8. So I have 2 to the power of x times 8 minus 5. And then I reorder it so that the 8 starts. And notice, folks, I put a dot for to show that the 8 is multiplying the 2x, just so it doesn't start looking like an 82. Or if you prefer to use brackets, you could do this or have the x outside the bracket. but you need to show that there is multiplication and that the 8 is not being raised to the power of x. Yeah.
You don't mind which one we use?
I don't mind, as long as you're showing me that 8 does not have an exponent. Okay? All right, so now that we've broken it down and simplified it as much as we can, now let's just get into the practice of stating what is the a value, what is the b value, and what is the c value. All right, nice out loud. What's the a value? What is the b value? And c? Yeah, good question. Is the b value 2 to the power of x or just the 2? Just the 2. It's the base. And what did we say, folks? We predicted, oh, if there's a d value, the a will change. And it did. Hooray! We did a great prediction. We are good math detectives. Da, da, da. All right, let's do another one.
Is it necessary to do predictions like this?
Yes. If you're asking me, then I will absolutely say yes, it is necessary. All right, next question. Question B. Which AKDC are we trying to get rid of? Okay, we're trying to get rid of the K, right? K value. What do we know about the K? What is it going to change, Timur? Are you sure of that?
Yeah.
Good. Okay, so because there's a K value, we are expecting. Now, Timur, you don't have to write the predictions,
Okay.
but definitely do them in our head. So our prediction is that the B will change, right? All right, let's see. And so let's remind ourselves that if I have ax to the power of 3y, that can be simplified or written differently, x to the power of 3 all to the power of y, right? This is the power of power rule. Power to power rule. And we're just doing it backwards now. We're undoing it. All right, so let's undo it. So carefully, we've got the 4, that's not changing. That's our a value, right? And so here, I've got 2 to the power of 3 all to the power of x. Remember to put the 3, the integer, inside the brackets. Once again, the c, I don't think it's going to change. Okay, the asymptote doesn't move. Makes sense to me. Okay, 2 to the power 3, what is it?
8.
Yeah, notice you're going to be really good at your powers. Am I done? Can I say 32 to the power of x? Really loudly. Can I do 32 to the power of x? No, Miss Light, don't do it. Don't do it. That would be horrible. That's right. We cannot. Yes. All right. So we are left with A equals, B equals, C equals. Team Wood had a prediction that the B would change. Did it? Yupperies. It did change. The A didn't, and the C didn't. Well, what happens when we have when we have both a D and a K? Da 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 da. And introducing question C, which has a D and a K. What? OMG. All right, watch this. What is the 2? What is the 2?
K.
It's a K. So this 2 is going to affect the B or the A? The B. And then there's a D value. What is the 5 going to affect? The A or the B? The A. Okay. So our prediction is that both are going to change. Okay. So in this situation, we must observe bedmas, right? Again, go into that grade 9 math class and just be like, dudes, do your homework. It's really going to matter in grade 11. Okay, so I go nice and slow. 1/4 stays. Now, Am I first dealing with the 2 or the 5? Or how about this? Take this back. Am I first dealing with the power the power to power or the product rule? Power of power. Reason being, this is 2 times x plus 5. So watch this. I break it down this way. 2 to the power of 2. When 2 exponents are multiplied, oh, take that back. Do you see what I just did? Okay, that's step 1. Well, I can't forget that minus 1. Now, before I move on, I will simplify. The 2 squared, I'll change it to a 4. So I'm like, oh yeah, I said the k value would change the base, and it did. So now I have 4 to the power of x plus 5. So how about this? Always change the base first, right? Always do power to power first. Okay, and now we can undo this by doing the product rule. So we've got 1 to the power of 4 times, and so here, because the exponents are added, we're breaking it down to 4 to the power of x times 4 to the power of 5 minus 1. Okay, nice and slow. So if this helps, first we undo power of power. Then we undo product rule. You don't have to write this stuff down, but it's there. Okay. Whoa. Anyone know what 4 to the power of 5 is? Don't tell me. I want us all to try to do it. Don't use a calculator. Use paper if you need to, or your head. Okay, take 30 seconds to do this. So 5 fingers. 4 times 4 is 16. Times 4 is 64. Times 4 is 256. I think it's going to be 1,024. Is it 1,024?
Yeah.
All right, good. Okay, now I'm going to skip one step, and that is that I'm going to write 1,024 first. I'm just going to change the order of the two. Right, so if you're not sure what I did here, I just move this here, that there, because they're being multiplied, so the order doesn't matter. So do you see how mental math is going to be really helpful here? Now tell me, what does this mean? 1/4 times 1,024. What am I doing? Am I actually multiplying? No. What am I dividing by?
4.
Yeah. Right, so it's actually, 1,024 divided by 4. Yeah, what is it, Luke?
It's 256.
It is 256, right? You could have been like, it's a factor of 4. Yeah, but I don't want you to do that. You could. But that would mean you're using your calculator, which we want to minimize. Bowser's. Folks, what a question that was. Okay, label ABCs and check. Oh, yeah, A changed. Oh, yeah, B changed. And did C change? No, C never changed. Yeah.
Are you gonna ask them if there's like which is A gonna change or is B gonna change or C gonna change?
Why not? Isn't that a great question? It's a great question. C doesn't change.
C never changes, yeah.
In these questions, in these questions, all we're doing is we're taking an equation and changing the form. I'm not transforming it. I'm just changing how it's written. So on a graph, the two equations look identical, right? Because it represents the asymptote. Can you change the asymptote? Absolutely. Change the C value, right? But that's a different story. That's a different lesson. All right. Okay. We see, oh, there's a K and a D. We're changing both A and B. We're changing the base and the uppercase A. Which one do we do first? Well, we undo the exponent law, the power of power law first. So I've got 5, 16 to the power of 1/2, all to the power of x minus 5. And this is where our knowledge of radical functions comes into play. What does an exponent of 1/2 actually mean? Yeah, it just means we're taking the square root of 16. Oh, interesting. So I get 4 to the power of x minus 5. So is it possible for the base to get smaller? Yup. If your exponent has a fraction, right, that will reduce the base. Okay. 5 times 4 to the x times 4 to the negative 5. Uh-oh, folks. We've got 4 to the negative 5. What's the word? What's the word? Reciprocal. Okay, so it's actually going to be 1 over 4 to the power of 5. Do we know what 4 to the power of 5 is? Is that 1024? Okay. So in theory, I've got 5 times 1 over 1024 to the times 4 to the power of x plus c. Oh, sorry, yeah, plus 6. And then I can't simplify these two. Like 1024 cannot be divided by 5. So folks, my a value is actually tiny. Like tiny. So what does that mean about your exponential function? Show it to me. No, it's not decay. Why do I know I'm growth? Which number shows me growth?
The base.
Yes. So the 4 tells me, okay, it's growth. But what does the 5 over 1024 show me?
That it goes from this to this.
Yeah. From this to this. It just grows much. It's almost like the rate of growth. It grows very slowly. What does the plus 6 tell me? That's right. It goes up by 6. That's where the asymptote is. Yes. Yes. All right. Let's do 2 more questions, and then I'll give you time to practice. Express the following in the form blah, blah, blah. The function f of x starts with 1/4 to the power. Oh, this should be to the power of x. Okay, so I have 1/4 to the power of x is my parent function. Okay, but we have a vertical stretch of 3. So that means a is 3. It's reflected in the y-axis. Is that a or k?
Okay.
Yeah. So k equals -1. And it's translated 5 units to the right. That means d equals 5. Okay, so now what we're going to do is we're going to add these to the parent equation. So I have my a value, that's 3. I have my base, 1/4. Now watch this. X minus 5, that shows the d. And then to show the reflection in the y-axis, we add a negative. Now, look at the parent function. Is it a growth or decay function? decay. Any predictions what we're going to end up with when we have, think about this, we have a reflection in the y-axis. Is it going to end up as growth or decay? Thank you, Luke. I see, like, you start like this, and you're doing a reflection. Watch me. What are you going to end up as? Interesting. What tells you, if you look at this equation, what part of the equation tells you that it's going to flip? The negative k value. That's right. All right. Okay, so let's simplify. We got 3. Yeah.
Why is it the K right now? Why is it the K?
That does what?
No, like,
Oh, why is it dk? Dk,
yeah.
if base is less than 1, it's decaying. All right, so we got 1/4 to the power of -1, all to the power of x minus 5. And the -1 just tells me, write the reciprocal. What is the reciprocal of 1/4? Oh, so that's how we get growth. And I've got x minus 5. Now we're going to use the product rule to simplify, to get rid of that horizontal translation. So we're going to get 4 to the power of x times 4 to the power of -5. Good old 1024, right?
No, because it's negative.
Thank you. Good old 1/1024. So did it end up as growth? Yes, it did. Right? And what is really interesting, folks, is that the horizontal shift, the -5, it changed the A value. So the A went from 3 to a really small number. And so, like, I don't know if you can wrap your head around that, but what it basically says is if you shift a function over 5 steps, it's going to look the same as a function would if it had a lower A value. All right, let's do this last question. Let's have you guys try this. So parent function is actually 2 to the power of x. Oh, horizontally compressed. Okay, folks, this is where we get confused. If it's horizontally compressed by a factor of 1/4, who cares about the compressed part? It's the factor part. The factor means that they're telling us 1/k. So when they say it's a factor of 1/4, they're saying they're giving us the 1/k. So what is k equal to? That's right. K equals to 4. Okay. So if they're given in a sentence, then you have to flip it, take the reciprocal. So please ask questions as they come up.
So can
Please.
base be, for example, 2x to the power of x? Or it's only
No, that sounds like a different kind of function. That would not be an exponential function.
Thank you.
Okay, now what's really important is that we add brackets when we have a k and a d value. Oh, but we don't have a d value. Yeah, what's up?
What's the other two? Like the -2 and then another.
So this one?
Yeah.
This is a base.
And
Right.
Base always do.
Nope. In the last question, the base was 1/4.
Oh.
Right? So they tell you in the beginning, they're like, the function f of x equals 2 to the x. That's the parent function of this exponential growth. Okay, go ahead and simplify it. So the way that I do this in my head, if it's 2 to the power 4, I take 4 fingers. And I go 2 times 2 is 4, times 2 is 8, times 2 is 16. Yeah.
Why is the x in the exponent if we started with?
I know, that's a typo. So it should have been 2 to the power of x. Yeah, thank you. Here, I'll cross it out. In this unit, the exponent, the x will always be in the exponent. Does that help, Sophie? Okay. And then I'm going to give you one more challenger. I'm going to find it from the homework.
But it's necessary to place the brackets around 16.
Yes. You could have done a dot.
Oh, okay.
You could have written -2 dot 16x minus 3. But you cannot say, oh, it's 216x minus 3. Do you see that? Yeah, don't do that. Okay, let's find one of the tricky questions that I know they're going to give you. Actually, I'll just make it up. Actually, I'll take that away.
I will have questions on quiz. For example, we will need to balance our sides. Like, so that they will.
All right, folks, simplify this one. Anyone feel like jumping off the desk? Oh, you're so sweet. Exactly. Did you see that? When you looked at this one, did you say, oh, I've got a common factor first? Right? I love that I'm putting these videos on YouTube. That was great. And then someone's going to watch it out of context and be like, who is this teacher? Now, is it possible to do it without common factoring first? It is. I'll show you what happens when I don't. But I think it's a good practice to just always common factor first, so that then you get the correct D value. I'm gonna. Oh man, my brain is tapped. Someone tell me what 9 to the power 4 is. Once you get there. Yeah?
6,561.
Did not feel like doing that in my head this morning. Okay, or I'll show you what happens if you don't. We will end up at the same place. Can anyone do 3 to the power of 8?
It would be 6,000.
Is it 6561? It should be, right?
Yeah. It's the same as.
Good.
Yeah.
So in theory, you can do it both ways, right? No right or wrong. All right. So we got over 20 minutes. Are you going to be ready for the quiz, or do you want it Monday?
Monday.
Yeah?
Yeah.
Really? Okay. If it was that easy to get applause. No, I don't mind because we're just finishing the lesson. But that means I'll do growth tomorrow. Okay, I'll do a lesson tomorrow that is not on the quiz. And then we'll do the quiz on Monday. Just because I feel like I want to give you more time to process this. Yeah?
Yeah. But it's like
Ben, what did I just say? We're going to do what? We're not doing a test. Yeah.